Question 21. When nitrogen dioxide is cooled, it forms a yellow liquid and then pale yellow crystals. These crystals are heated, and the temperature is measured every minute. The following graph can be drawn. So this graph is the heating curve. Describe the arrangement and movement of the molecules in the region A to B. A to B, we have the solid particles. So we here have the arrangement and the movement, 2 parts. Regarding the arrangement, we would write the points here and here regarding the movement. So regarding the arrangement, the particles are closely or tightly packed in a crystalline lattice regular pattern. Regarding the movement, vibrate. In other words, you can say vibrational movement. So 1 mark here regarding closely packed, the 2nd mark regarding the lattice structure, and the 3rd mark regarding the movement, which is vibrational. Name the change that occurs in the region B to C. B to C. B to C, what happens here? Melting takes place. So the answer is melting. Question 22. The kinetic theory explains the properties of solids, liquids, and gases in terms of the movement of particles. Liquids and gases both take up the shape of the container, but a gas always fills the container. The gas fills the container. Explain this using the ideas of the kinetic theory. So here, liquids have fixed volume, but they take the shape of the container, while gases, they don't have a fixed volume or a fixed shape. Explain this. And this question is out of 4 marks. So 2 marks for the liquids and 2 marks for the gases. So first, regarding the liquid particles, and here regarding the gas particles. So we have to talk about the arrangement and the movement. The liquid particles are very close. They are touching each other. They are randomly distributed and slide over each other, having a fixed volume. So liquids have a fixed volume. They are very close, touching, randomly distributed, slide over each other. If you write this, you take the 2 marks regarding the liquids. On the other hand, the gas particles are very far apart. They are randomly distributed and they move randomly in all directions. So they spread or move or diffuse and have no fixed shape or volume. So we highlight here the keywords. They move randomly in all directions, have no fixed shape or volume, and very far apart. The following apparatus can be used to measure the rate of diffusion of a gas. This is a gas syringe. The gas syringe is a laboratory tool used to insert or withdraw or measure the volume of a gas. So here, what measurements would need to be taken to calculate the rate of diffusion of a gas? So we have here grading. It is graded here. We have constant pressure applied through the plunger, and we have a metal foil where gas escapes through the small hole here, and the gas is inside. What measurements would need to be taken to calculate the rate of diffusion of a gas? To calculate the rate of diffusion of the gas, we need to measure what? We need to measure the volume of the gas lost per time. So the gas is here, it will diffuse, so we measure the volume of the gas lost over time. So what measurements? The volume of the gas lost per time. Which gas, carbon dioxide or sulfur dioxide, would diffuse faster? Explain your choice. This question is out of 3 marks. So we have CO2, which is carbon dioxide, and SO2, which is the sulfur dioxide. Which one will diffuse faster? Here we have 2 oxygen and 2 oxygen, so we'll compare the carbon to the sulfur. If we check the periodic table, we'll find that the relative atomic mass of carbon is equal to 12. On the other hand, the relative atomic mass of the sulfur is 32. So which one has a higher relative molecular mass here? Here 32, here 12. So SO2 will have a higher value of the relative molecular mass. In other words, the SO2 is heavier. So why carbon dioxide will diffuse faster? Because the carbon dioxide has a lower relative molecular mass than the sulfur dioxide. In other words, CO2 is lighter, so it will diffuse faster.